Okay, in the last video I showed you how easy it was to create a simple web application using Spring Framework. And what we did was actually fairly complicated. There's a lot going on underneath the covers that are being handled by Spring Boot for us. So by including a couple dependencies in our project, when we run it, Spring is seeing that we have a web application context that is bringing up an embedded Tomcat server for us. It's also wiring in Hibernate for us. Spring Boot sees that we're in a development mode, so it provides us an H2 in-memory database, but it even goes a step further than doing just that. It's actually using Hibernate, and through commands in Hibernate, it's looking at our entities, and it's going to create a database. So it's if you're familiar with SQL, it's Spring, through Hibernate and Spring Boot, it's actually going to be creating database tables for us. So the database gets created, and then I set up in the initialization class of Spring Boot to insert data into the database. So we have an in-memory database coming up in H2 that's being set up by Spring and Spring Boot using Hibernate to extract the DDLs for the tables, and then those tables get created in the database for us. So we come up, we're running inside a Tomcat, we're not creating a war or anything like that. So we're running inside a Tomcat, we have the in-memory database all set up for our use. And part of the initialization is that we insert data into the tables. Through just a little bit of code, we were able to do quite a bit. You saw how I set up a time leaf template, set up a Spring controller, and then we queried the database through standard JPA utilities and returned it back. Now, I did all this in a non-typical Spring way. I'm using pure Spring and Spring Boot here. I'm not getting into any external projects. And yesterday I told you I've had the opportunity to have some very good mentors along the way, and I've learned how to do things the right way. And I've been in a lot of different client environments where I saw code written exactly like this, where you are doing a lot of stuff in the controller. So if you take my courses and go through the videos, I harp on things like single responsibility principle quite a bit. It makes your code better and easier to maintain, because at the end of the day, I don't think any software developer wants to be producing buggy code. And it's just having good work habits and knowing how to construct your classes. And what I'm going to do in this video is show you how we can make this project more a typical Spring project. And we're going to tackle some very common ways of using Spring, using dependency injection, allowing our classes to have one function in life. Our controller should only have a single function in life, and that's to respond to a web request. We should have a service layer, and that service layer is going to handle a request from the controller. Something I'm going to introduce in this module here is Spring Data JPA. So you saw in the last example, we were using pure JPA, working with an entity manager being provided by the Hibernate context for us. We're going to get rid of that completely, and I'm going to show you just how easy it is to work with Spring and get data out of a database using Spring. So we're going to cut out a lot of the fluff that we had in there, and we're going to wind up with a much better code base, something that's more targeted, less code, less risk of bugs, and in the long run, the style I'm going to be showing you is going to be much more maintainable and lead to higher quality code. Okay, back to their project here. Since the last video, I did check this into GitHub, and I will leave you a link of this version right now, and I will also give you a link of the final version. So what I'm looking at here is we are getting a hold of the application context. And I have a general rule of thumb inside of Spring. If you're getting a hold of the application context for any reason, you're probably doing something wrong. If you feel a need for that, you might want to reconsider what you're doing. Just a little voice of experience. There are legitimate times where you do need to do it. But when you are doing it, sometimes what you're doing is wrong. So the first thing that we want to do to make this a little more springy is we are going to introduce a concept through Spring Data JPA. And I'm going to create a package called repository. And what we want to do is this file's a repository pattern. The repository pattern is something coined by Martin Fowler. And it sets up simple CRUD repositories, and the Spring Data JPA project took off from that. So I'm creating a product repository, and I am going to add that to Git for you guys. And what we want to do is we want to come in and extend a CRUD repository. And you can see there it says T and ID, so this is Java generics. So we are going to do this, and we want to do product. So you can see the Guru Spring Framework.domain, so that is the right instance of product. And our ID was an integer on this. And I got one mistake there. This is actually an interface. And now we are happy. So this is a CRUD repository, and let me jump over to this real quick and show you what we are implementing. So we get a repository, it's an interface, and we get a save, find one, find all. We can do a find by a set of IDs, get a count, and we have delete operations as well. And this also extends repository, and there's really no implementation of that, or no methods being implemented. So what is going to happen under the covers here using Spring Data JPA? So this is very important to understand, is because I am declaring this as an interface, this is going to get scanned, and Spring Data JPA is going to provide us an implementation of it. So Spring is going to do reflection, look at this, look at our domain class, and provide all the JPA stuff for us. And now we'll be able to use this within our project, and we don't have to code anything. So this is a huge benefit for us to use. Now the next thing that we need to do to enable this is we are going to create a configuration class. And we'll do it in the package here. And I'm going to spell that right. So we'll refactor this. And I'm going to add in a new Java class, JPA config. And this is a convention that I follow because I want to make sure that this is a Spring configuration class. So we want to do enable JPA repositories, and we're going to tell Spring where these are at. So you can see the autocomplete there. And this is an annotation, and it's going to tell Spring Data JPA to look here. And just so you understand, when I have a web application, what Spring Boot does is it does a component scan down, and so it'll see this being under configuration, a package underneath Spring Guru.Spring Framework, so it'll get picked up in a component scan, and that annotation will get seen by Spring Boot, so our repositories will get wired in. Now the next thing that we want to do is, here we are loading up data in our application class, and that is absolutely awful. Not something that we want to be doing in production for sure. So let's resolve that little problem right now. And I am stealing this. This is directly from the Grails community to do Bootstrap. Just like Spring Boot, Bootstrap, or computer booting up. If you are not from the US, you might not be familiar with this saying. In the United States, there's an old saying, pull yourself up by the bootstraps. And this goes back to the cowboy days. Yeah, we don't really need that called bootstrap, so let's refactor that real quick. Saying bootstraps. And if we implement an interface called application listener, and what I'm going to do is implement a class called application listener and listen for the context refresh event. And I'm going to say this is a Spring component. And it's not happy, so if I do this, and I'm doing generate instead of IntelliJ, so it wants us to implement that. So this is a type that we are implementing, and Spring is going to look at this, and when we get a context refresh event, this method is going to get called. So that is important for us. So, and this is an event that gets tossed when Spring starts up. So this is a quick way for us to hook into startup events and load our database. Now what we want to do is I'm marking this as a Spring component, so it's going to be a Spring managed component. And let's create a constructor for this. Oh, before we do that, let's do private. And we want to get the product repository to come up. There's our product repository. Repository is just fine for that. Now I'll do a control N constructor, and we want that to come in, and we will say auto wired. So these annotations are saying that this is now a Spring managed component, and the Spring context is going to manage it. So Spring is going to create an instance of this and register it with the application listener. So this bean will get called, but this bean will get configured with an instance of the product repository from Spring Data JPA. Now I'm going to come over here and clean up this very bad stuff from here. We no longer need that. I'm going to cut it, and we are going to jump back over to the Bootstrap. And what we are going to do is, do not do this at home. You should not be doing cut and paste. And we only want these guys. And I don't have to do any more of the JPA stuff, so that all goes away. This EM merge goes away, and what he is going to get replaced with is repository.save and product 1. And I'm going to do the same here for product 2, product 3, and this EM transaction goes away as well. So now this is a much cleaner way of doing what we were doing before. So you can see that this class has a single function in life, and that is to load up our data on startup through the context refresh event. So this is a much nicer implementation of it. Far better than what we had. You can see in our web application, we can even get rid of this, and our application goes away. So we're no longer messing with the Spring application context. Now, the next thing that we want to do is take care of our controller. And all this nonsense needs to go away. And what I normally do is I create a service layer. And in this case, I would normally do something with the service layer. This is a fairly simple example, so we can access the repository directly, but I want you to understand the concept of using a service layer. So I am adding in a private property there, and I'm going to do a constructor for the repository. Now, this stuff that we don't need to get a handle on the request anymore, so we're not going to ask Spring to provide that for us. This all goes away. The entity manager goes away. Now, all this goes away, and all we need to do is repository, find all, close, boom. So now you can see our controller has a much cleaner application. And normally what I do here is I would create a product service and a service implementation and inject that repository into it. That would be a little more springy way of doing this. But you can see that the concept is the same because I am auto wiring in an interface, and Spring is going to provide us the implementation of that interface. So it's very, very important concept to understand with dependency injection, is that we are using an interface, and Spring, in the Spring context, is deciding what implementation to provide us. And a good example could be I could be unit testing this, and I'd want to put in a Mockito mock and use a mock object for the product repository, and I could run it completely outside of the Spring context, provide a mock object, and this code would function and return back whatever the mock returned and the model, or I'm sorry, the string product / list if we were to execute the list products method of this class under a unit test. So what I'm going to do now is let's go ahead and refresh this. And this is So I'm restarting Tomcat. I asked it to restart. I still had it running from the last lesson. And we can see that it is coming up and there are no errors. So I'm going to toggle over to Chrome now. And let's see if it works. And boom, the application worked. Okay, now we started off this module, and I had a typical Java web application. I tried to mimic that a little bit and avoid using some of the features of Spring, such as dependency injection. I've seen a lot of websites develop with this. I've actually seen, literally, and I hate to admit this, I didn't write it, but I've seen controllers with over 1,000 lines of code and a controller method, which is just obnoxious. That you cannot properly unit test something like that. And that code base, it was like playing Jenga. You're afraid to touch anything because you might break it. It was very brittle. It was very difficult to maintain. And it was very old code, too. So things have evolved quite a bit. Java used to be considered slow. J2EE used to be considered overly complex. Spring used to have those same criticisms as well. And in some circles it still does, because when things do break in Spring, it can be difficult to resolve. But I just showed you how easy it is to use some of the Spring projects to save yourself time. So Spring Data JPA is a really cool project. I'm a big fan of it since its early days, to be honest, because it does save you so much time when you're working with JPA objects like that. So you saw me, I did move through this a little bit fast, but I provided an interface for the product repository, and Spring Data JPA, when it comes up, it's going to provide that implementation. So that implementation is getting generated for us dynamically at runtime for us. And it works out quite nicely because we are not having to mess with the entity managers. We are not messing with transactions. So that's one thing I didn't mention in it. In the videos when we step through the code, there is a transaction. It is transactional. So if that save failed for some reason, if a database constraint popped, or if the database was down, our transaction would be rolled back and we would get an exception out of it. So these are all important features. You are seeing, or you're not seeing it, you're not handling the code for it because the Spring framework is providing that for you. And now we have a much cleaner implementation. You saw a lot of code went away. We're not messing with the Spring context anymore. We are using a Spring event to load up the data for us. And this is something that you commonly do to set up your data in a known spot for your testing. And our controller became much, much cleaner. We went back to the single responsibility principle, where our controller was doing one thing. Our controller is not going out and accessing the database. That is not managing transactions. Now that repository object could be any implementation. We could provide an interface that actually calls out to Spring integration and invokes a message flow and goes back into a deeper corporate system to get back the request for the controller. So now what this is doing, before the controller was tightly coupled. It was tied to JPA and the entity manager factory coming back. So that code was absolutely coupled. Now our controller is independent of how it gets that product data. It doesn't care. That repository is being provided for us by Spring Data JPA. But if we want to provide a different implementation, I pointed out, like unit testing, if we're unit testing it, that implementation of the controller could be provided by Makito, and our controller code would just work fine because it's no longer tightly coupled. It's now removed from it. And this is considered a development best practice, because you do want to be following good object-oriented principles, and you do want to be producing code. And this is one of the things that I'll teach you in my courses, how you can work with Spring, the Spring framework, and produce quality code. Because, like I said before, I don't think anybody wants to be producing crappy code. I'm the type of developer where I want my code to go into QA, into production, and not produce any problems. I'd rather have the code just run, and I don't want to be bothered at night. I don't want to hear, hey, your code's producing bugs. I don't want to hear things went down because your code crashed something. I don't think any developer does. We want to do a good job. We want to have our code work, be fast and efficient, and not cause problems. So by adhering to common practices such as the solid principles of object-oriented programming, It's a good practice. By using dependency injection, by having loosely coupled code, these are all good practices, and they lead you to better quality code.